In this tutorial, we'll walk through the process of adding a scripted component in SimulIDE to create a DC power meter. We'll begin with a brief overview of the theory and then see how it integrates into the SimulIDE environment. A scripted component in SimulIDE is made up of 3 files that work together, as shown here. Each file has a specific role. One defines the behavior, one defines the structure and configuration, and one defines the visual representation in the circuit. The .as file defines the behavior or logic of the scripted component. It is the AngelScript code which handles the input and output pins, internal state logic, and simulation behavior. The .mcu file acts as the component definition or descriptor, linking everything together. It references the script file, the .as file. It lists the pin definition, which are the names, directions, and types, as well as the component properties and default settings. The .package files define the visual representation and pin layout in the schematic. It defines the component drawing or symbol with pin positions, labels, and graphical layout. The content of these 3 files are shown. The .package file at the top defines how the component appears in the schematic, including its symbol and pin layout. The .mcu file, bottom left, acts as the configuration layer, linking the script, defining pins, and setting default parameters. The .as file, on the right, contains the actual logic written in AngelScript. It controls how the component behaves during simulation. The instructions in this .as file really looks like C code, but it isn't. This is then an example of the scripted component usage. In this setup, we use a 9-volt battery and a 100 ohm resistor. A voltmeter is placed across the resistor to measure the voltage, and an ammeter is placed in series to measure the current. These 2 signals are then fed into the power meter component as the component inputs. We can see that the power meter output is displayed in the console window, showing the calculated results of the circuit. Our zip folder is available via the link in the description below, and it is the complete SimulIDE workspace structure as shown, which contains the 3 files. I've named the folder in the workspace test for my test equipment. This zip file can be downloaded, unzipped, and placed anywhere on your system. In this example, it is stored in the Documents folder, but it can also be copied directly into the SimulIDE directory, as shown below in the bottom right. The key requirement is to ensure SimulIDE knows the location of the scripted files. To specify the location of these scripted files, open the Settings menu in SimulIDE by clicking the gear icon in the toolbar. Then click the 3 dots button and browse to select the SimulIDE workspace folder that was previously downloaded and extracted. Finally, restart SimulIDE for the changes to take effect. The downloadable files are available in the description below. This includes the instructions document named Scripted Component DC Power Meter.pdf and the zip archive SimulIDE workspace.zip, which contains the 3 required files. Okay, so once you've extracted the SimulIDE workspace folder, you copy it into the directory where you are working. I copied mine into the application folder, so there's SimulIDE workspace. If I go in test equipment, I see there's my power meter, so there are the 3 files. If I run SimulIDE, just to show you, if I click on the gear, I will see user data folder. This is pointing to that SimulIDE workspace. So it's picking up the scripted files from here. If it's working correctly, I can scroll all the way down. I will see there is the test for my test equipment. There's the power meter, which I then can pull and place in my circuit. So only thing left to do is to wire it up. So I'm going to need a voltmeter. I'm going to need my ammeter, and I need my circuit. So I'm going to place a battery. I'm going to change its value to be the same as the example, 9 volt. I just want to rotate the text. I want to add my resistor. So the wiring goes current through the circuit, voltage across the resistor. So I'm going to measure the voltage across the resistor. And I need to add a ground point. Okay, so the voltmeter output goes to my power meter input, and my ammeter output is the second input. Okay, so now it's wired up. I've got 9 volt divided by 100 ohms will give me 90 milliamp. This will give me 9 volts across it, so 9 volt times 90 milliamp will give me 0.81 watt. So if I simulate this, I can see there's the values, and I get 0.81 watt. Now, something that you can also use just for a visual is the probe. If I wire up the probe, just remember the units will be incorrect because the units for the probe is in volts, but I'm measuring watts here. So when I simulate it, I can see the value is correct, but the units is incorrect. But it gives me a bit of a visual. So I hope you find this helpful.